The Faculty of Exact Sciences, Professor Chaim Wolfson, university faculty, students, high school students, and guests. It's a great pleasure for me to welcome you all here today at Tel Aviv University. For those who don't know me, my name is Colin. I'm the head of the Department of Geophysics and Planetary Sciences at Tel Aviv University. Our department has a long record of research and cooperation with NASA, and more specifically with Ilan Ramon and his colleagues, such as Michael Massimino. Our Department of Geophysics cooperated with Ilan Ramon on the MADEX experiment on board the Columbia Space Shuttle. We worked for a number of years with Ilan Ramon on the joint scientific mission. Although we all know about the tragic end of the mission, I would like to emphasize that the scientific mission was highly successful. In the continuation of our collaboration with Rona Ramon and the Ramon Foundation, we recently opened here at Tel Aviv University a new renovated student classroom dedicated to the memory of Ilan Ramon and one of our faculty members who worked closely with Ilan, Professor Yoachin Yosef. Today we welcome Michael Massimino to Tel Aviv University. This is Michael's second visit to Tel Aviv University, and during his previous visit he met with the then president of Tel Aviv University, Professor Tzvi Galil, and he received a flag of the university to take to space on his flight 1 year ago in May 2009. In addition, Michael received a mezuzah from Rona Ramon that also made the trip to space and back again. And today Michael has come to Tel Aviv University to return the flag to Tel Aviv University and the mezuzah to Rona. Michael Massimino was born in New York in 1962. We're the same age, Michael. He received his PhD in mechanical engineering from MIT in 1992. In addition to being a NASA astronaut, he's also an adjunct professor at both Rice University and Georgia Institute of Technology. Michael joined NASA's astronaut training program in 1996 and has flown on 2 space shuttle missions, the first on Columbia in March 2002 and the second on Atlantis last year in May 2009. Michael has spent nearly 24 days in space, with 30 hours spent floating outside the space shuttle during spacewalks. Both these missions were to service and fix the Hubble Space Telescope. As a result of the last mission a year ago and the hard work of Michael, the Hubble telescope now has 4 new instruments, new batteries, new gyroscopes, and a new computer. Before we start with the presentation of Michael about his experiences in space and fixing the Hubble telescope, I would like to ask both Michael and Dean Wolfson and Rona Ramon to come to the stage so that Michael can officially return the Tel Aviv flag to the university and the mezuzah to Rona. Unfortunately, the university president was called away at the last moment, and therefore the flag will be returned to the Dean of the Exact Sciences faculty, Professor Chaim Wolfson. This flag will hopefully find a permanent home in the Ilan Ramon student room in our department. So if you could all please come up.
Sure.
Maybe you can assume.
Okay. Can everyone hear me okay?
Yeah. Stick that in your pocket.
Okay. Okay, we're ready? All right. This is really a great honor for me to be here today. I'm very glad Colin helped arrange this, and of course my good friend Rona. It's wonderful to see you again. And I knew Ilan very well. He's a very good friend, a great astronaut, and just a great person. And when he was not able to come back and return the items that he had taken with him, not all of them made him back, of course, and I wanted to do something to honor Ilan and Rona and the family and the school in Israel on my opportunity when I flew on SES-125, which I'm going to tell you about through the slides. And we thought of two things. One was to fly something for Tel Aviv University, and the other was to fly something in honor of Israel and try to replace one of the items that Alon took but wasn't able to return. So we'll start with the flag, and we're going to make a little ceremony out of this. I have not seen the flag since it was handed to me a couple of years ago. It arrived in the mail from Zvi, and it was put in this vacuum-sealed envelope that you see here. And we're going to cut it open, and hopefully it looks the same as you. We're taking a bit of a risk. Hopefully no one wrote anything on it, and written NASA. But we're going to ceremonially cut this open with our scissors that we have over here. Okay, we've got to be very. We don't want to cut the flag, so this is a little tricky. Okay.
Did you all come to your right a little because of all the cups and
In the floor. So we flew this on our flight to honor the school that Ilan Ramon graduated from, and for all the students and faculty here at Tel Aviv University.
Michael, look at that. Thank you.
I just want to add that Ilan took a special stone with the same symbol of Tel Aviv University with it, and when Michael asked to do something together, it was really meaningful for all of us, of course.
It was an honor for us to have this on board with us.
Michael, can you come closer?
Yes, certainly.
Well,
we have something that goes with that. We have something that goes with it. This is also for the school. This is a Israeli flag and a patch that flew in space as well, and it goes along with the flag for you to have it. Some pictures from our mission, our crew, and spacewalks, and the telescope, and so on. So that's for you as well.
Thank you very much. It's a big honor for us to have it.
Okay. What's that? Have you seen this? We've got another one. And then the other item we had, I called, when I got assigned to my flight, which was a long time ago. It was October. You celebrate Halloween here in Israel? You have that holiday? We have an American holiday. Did you celebrate it when you lived in the States? Did your kids dress up? In the States, we have a holiday called Halloween, which the kids dress up in costumes and get candy from the neighbors. And it's on. That's how I remember the day I was assigned, because it was on Halloween of 2006, October 31 of 2006. I was assigned, and I called Rona shortly after that and said, what can I fly for you and Ilan, your family, for Israel, and so on. What would be a meaningful thing to fly? And I think you thought about it for a while, and then got back with us, and Marty, of course, helped us with this as well. What could we do? And do you want to say anything, how you came to the conclusion that we would do this?
Yeah. This mezuzah actually was made by a very special artist in Los Angeles. She belongs to a club which called 39 Club. This club is actually a club for survival of the Holocaust and the second generation. Ilan got to know those people in a very close connection, and he decided to take this mezuzah with him. Actually, there's a movie that you can see Ilan explaining about this mezuzah. So it's a very special mezuzah with a barber on it, תיל על זה, שמסמל גם את השואה, the Holocaust, and Israel. And when Mike asked me, I thought that this will be the most appropriate thing to respect Ilan's wish and to take this with him to space. And of course, we're very happy that Michael is here and the mezuzah with him. So we appreciate the moment.
And I appreciate the opportunity to take that with me. Ilan meant a lot to us, and Rona, of course, you and your family did as well. And the relationship between our countries, between the U.S. space program and the Israeli space program, was a very important bond, and I'm glad we're able to keep it going with events like this. But it was very, very meaningful. It was really a great honor for me to be able to take this mezuzah on my space mission. So thank you very much for arranging us to have such a special object with us.
Thank you.
Okay, and that also comes with. This is for your family as well. Israeli flag and patch from the mission.
Beautiful.
Thank you very much.
Okay, thank you.
All right, thank you. Do I stay up here?
Yeah, you just got to
Okay, I'll stay here. Yes, that's all.
Okay, thank you, Anna and Professor Wolfson. Now we'll move to the talk given by Michael about his travels in space. Let's try to bring the lights. Pushing too quick.
Everybody doing okay? Okay. I only have one choice of language, which is English. I'm a typical American, I guess. And so if I'm talking too quickly, or in fact, a lot of people in America can't understand what I'm saying because I'm from New York. So maybe that might make it better here. But if I'm speaking too quickly or you don't understand what I'm saying, please just slow me down or yell or do something to get my attention. But it's really an honor for me to be here. I've been here a couple times before. It's really wonderful to be back and to tell you about what I've been doing and what I did about a year ago when we flew up to the Hubble Space Telescope. This is our patch, and this is where we went. Most of the space shuttle missions in the past few years have gone up to the International Space Station. Ours was kind of the different one amongst those missions, which went up to the Hubble Space Telescope. So that's where we went, and that's what it looked like as we approached it. And this is a crew that I went with. This is during a training exercise we had at the Kennedy Space Center. And the person driving the tank, this is an armored personnel carrier that we all get practice driving just in case we have to get away from the spaceship on launch. If something, if something's gone wrong, we need to get away safely. We drive this armored personnel carrier to protect us as we go away. And Megan is driving at this point. Megan Macarthur was our robot arm operator and our flight engineer, and this was her first flight, and she's in the front. And in the back is the guys. So Megan was the only female on the flight. And all of the guys were all about the same age, mid-late 40s. And Megan is in her 30s. So she was quite a bit younger than all of us. So when people would ask her, she would say she was going to space with her 6 older brothers. And then if she was being really honest, she would say she was going to space with her 6 annoying older brothers. So that's how she would describe it. But she was stuck with the rest of us. And in the back on the left is John Grunsfeld, who was making his fifth trip into space and his third trip to the Hubble Space Telescope. He was our lead spacewalker, which meant he was the one that worried the most out of all of us on the flight. Then right next to him is me, the big guy next to him. And then right below me is Mike Good, who just came back from his second space trip a week and a half ago. Mike was on his first trip with us going up to Hubble, and he was my partner when I walked in space. It was his first flight. Next to him is Greg Johnson, who's our pilot. He's a Navy pilot, and it was his first trip. And another first-time space flyer is next to him, Drew Feustel, who is a geologist in his background, but he was a spacewalker on our flights. And then the big guy on the right is Scott Altman, who was our commander. We did a lot of training. We were assigned together for about 2.5 years. We had a couple delays in our flight, but by the time we got there, we had been for training for about 2.5 years. And a lot of our training took place in the pool that we have at the Johnson Space Center. It's a very big pool. It's 100 feet wide, it's 200 feet long, and it's 40 feet deep. I'll leave the metric conversions to you. Again, I'm American, so this is as best I can do is English units. But they would lower us in the pool, and we would work for about 6 hours practicing our spacewalks. For each spacewalk, for each hour of spacewalking that we did, we practiced about 16 hours in the pool. So for every spacewalk we did, we practiced it 16 times over those 2.5 years in the pool. And we had a total of 5 spacewalks on the flight. For me, I'll show you this picture because it refers to something a little bit later that you'll see in a video. We normally, when we work on the telescope, we would replace a whole unit. We would take an instrument out that had failed and put a new instrument in, brand new. It didn't matter what was wrong with the instrument. It's kind of like you have a refrigerator, the light bulb goes out, you don't replace the light bulb, you get a whole new refrigerator. And that's kind of your car runs out of gas, get a whole new car, don't fill it again. That's kind of the way it works with these instruments because they weren't meant to be repaired in space inside. They would just take the whole thing out, put the new one in. Well, one of these instruments, the Space Telescope Imaging Spectrograph, had a power supply failure, and they did not have a replacement for the entire unit funded and built. There was nothing. It had died, and that was it. It was going to stop. It was going to stop its science. Well, the scientists had liked this instrument, and they wanted it back. It could detect the atmospheres of distant planets, and they had just kind of discovered how to use this in unison with some of the other instruments, so that they were very hopeful that as they identified planets, they could use this instrument to analyze the atmospheres and then maybe find an atmosphere of a planet that was similar to Earth, and this would be a great, substantial finding. But the instrument stopped working, so they came up with the plan for us to go inside and pull out the power supply card, which looked like a computer board, and put a new one in. And here I am practicing with a special tool. This is a power drill that a power tool that we developed for the mission, for this task in particular. And all those little dots that you see in there are little holes that are aligned with screws. And there's 117 small screws that need to be removed. So I can remove the plate and then get inside of there, remove the card, put a new card in. The new board just had a couple handles to throw, and you have to put all the screws back, luckily, and then that would fix the instrument. But it was getting all these screws out that were a problem. The thing I want to point out to you that you'll see later is this. There's a gold handrail. You can see a stanchion up there, up top. You see that thing up there? I don't have a pointer, but I have to put my finger. Okay, there's another one down here, and there's a handrail between them that has already been removed in this picture. That gave me trouble that you'll see in the video. But I practiced for many hours. This was the task that had me most concerned was this one, getting ready for the flight. So it was a lot of training, and then it was time to go and launch. Our mission had initially, before we were assigned, after the Columbia accident, looking at the missions that the shuttle was going to fly, they didn't like the idea of sending anyone to Hubble because there was no safe place to stay at Hubble. If you go to the space station, there's a problem with the spaceship, you can't come home. You can stay at the space station until you can figure out a way to come home. But going up to Hubble, there's no life support, so if you find out there's a problem with your spaceship, you're kind of stuck. So the solution that NASA came up with was to have another spaceship. You see Atlantis on the left and Endeavour is on the right there. It would be ready to go to come rescue us if we had any trouble. So there was a crew that went into quarantine soon after we did that would be ready to launch and come get us. We were very nice to these guys, by the way. We didn't want to get them angry, so they'd be motivated to come get us if need be. But so this is the interesting thing about this picture is you have 2 space shuttles on the launch pad ready to go, which we'll never see that shot again. Okay, then here's some video of the launch.
Houston, you are go for orbit up.
Houston, Atlantis, good work. Go for orbit up. Thank you.
Okay, so that was our launch. And I know a few people in this room. Raise your hand if you've ever been on a space shuttle launch. I know Rona, of course, has, and Marty has, but a few people here, okay, scattered. Yeah, it's a very powerful experience, yeah? And you can feel it, right? It's an emotionally powerful experience. And so sitting on top of this thing is quite extraordinary. I felt as if, you see, it was a beautiful day. It was nice and sunny. And you're laying there on your back with your friends, just like you practice. About a month ahead of time, you go down there and you practice all this. But it's different on this day because now there's fuel in the tank, and you're actually supposed to go somewhere. And so you're laying there, and it's again a nice day, and it's beautiful and everything. It's nice and quiet, and you get down to a few seconds, and at 6 seconds, the main engines, the 3 main engines on the shuttle, they light, and the space shuttle does a little pitch maneuver. It pitches and then it comes right back, and when it comes right back, it's pretty much at 0. And the solid rockets, the white rockets on the side, light. And when those light, the thing's going, and you go, it's as if I felt like I was grabbed by some kind of monster, some kind of science fiction monster had grabbed me by the shoulders and was taking me far away from home. And there was nothing I could do about it. We were just on our way. It's just this awesome feeling of power and speed is the way I would describe it to you. That we were on our way, and we were going really far away, and really we had very little to say about it. We were just going to go, and that's what I felt like. So
you're not in the big one. In the big one, center.
Well, the orange thing in the center is a fuel tank. And that fuels our 3 main engines. The white stick on the right side there, that's a solid rocket. There's another one just like it on the other side. And you can see the space shuttle there on the left side of the stack. And so we're at the top of that, where you see there's the black, there's at the nose there's black, that's some of the tiles, and in the windows are just below that. And so we're in that crew cabin going out.
I'm sorry, does the rest of that disattach once you're in space?
Well, what happens is that after 2.5 minutes, the solid rockets burn out, and they return to Earth, and they get picked up and reused. They repack them with propellant and reuse them. And then you ride for 8.5 minutes. You go from 0 to 17,500 miles an hour in 8.5 minutes. And so there's a lot of acceleration going on. And when you at the end of the 8.5 minutes, the main engines cut. The fuel is cut off from the engines, and everything is nice and peaceful and quiet again. And then a few seconds later, the big tank falls away. It has these explosive bolts that break its connection with the space shuttle, and the big tank will fall down. It breaks apart, though. Big chunks of it go into the Indian Ocean. It doesn't. We don't reuse the big tank again. So, go ahead.
Why do you need all of this part that finally don't actually be with you in space? Why do you need all those things? Why can't it just be one part?
Why can't it just be one?
One part that it all applies to space.
Yeah, well, when they first designed the space shuttle, they actually had, the initial idea was to have like two vehicles. One big one that could take the space shuttle orbit, and then it would fly back and you'd reuse the whole thing. But that didn't work. So they looked at it was too expensive to do that. So it was just a combination. It was kind of a combination of things that could get you where you needed to go for a reasonable price. Okay, and you couldn't make your fuel tank too big, and you want to be able to fuel your main. There's only so much you could do with those main engines that you had. You needed the extra little boost, or actually a pretty big boost from the solid rockets, and that's the design that they were able to come up with. So it was kind of a combination compromise that gave them this design. Okay. All right. So we were up in space for a couple days, and on the third, after we launched, and on the third day, we rendezvoused with the telescope and grabbed it, and then the telescope was placed inside of our payload bay, and we were able to spacewalk on it. I'm hearing a bunch of clicking. I'm sorry. I've got this attention deficit problem. Is there some kind of beeping going on here or something, or texting or something? If you wouldn't mind silencing that, I'd appreciate it. Sorry. Okay. All right. Thank you. All right. After we grabbed the telescope on our third day in space, we started our spacewalks. And the spacewalks began on day 4, and they ran for 5 days in a row. And here I am on the right in a blue shirt, and I'm helping John Grunsfeld put his pants on. It's kind of like getting your little kids to get ready to go out and play in the snow. So that's what we're doing. You need help to get dressed inside of this bulky suit. And on the first spacewalk, our primary objective for John and Drew were outside, I was inside, was to replace the wide field camera. And this is the camera that takes the really cool Hubble pictures that you see that they sell the calendars for and make these nice picture books and album covers and stuff. It comes from this camera, and that's what they did on the first spacewalk. But right away we had a problem. What happened was that the bolt on the old one to take it out, it's just really just one bolt that holds the thing in there. And Drew, it was his job. This is his very first space flight, his very first spacewalk. His job was to loosen that bolt, which we thought was going to be pretty easy. But what happened was that it was a little bit too tight, and that we had a wrench that had a torque limiter on it. So that meant that so he wouldn't put too much force, too much torque into the bolt. This device, this tool had a protection on it so that it would slip. And so he tried it, and it slipped. He wasn't able to undo this bolt. So we went to a different setting, and he tried it again, and it slipped. It slipped again. So he wasn't able to put enough force in there with the protection unit on there. And so what we had to do is we told him to take that protection away, the thing that was going to prevent him from breaking the bolt. Because once if he broke it, the telescope would be okay, but you couldn't replace the instrument. So this multi-million-dollar, many very expensive instrument would never go in, and we would never get any cool pictures. So it was Drew's job on his first spacewalk to make sure that he put enough in to break the torque on the bolt, but not too much, because he would break the drive rod, and then we'd be in trouble. So I was really glad I was inside telling him all about this, of what he had to do. But he's a pretty cool dude, and he got it just right, and he got the bolt loosened, and the new one went in, and so on. So that was the drama on the first spacewalk. On the second spacewalk, that's Mike Good upside down holding one of our gyroscopes. that we replaced on the telescope. And there I am down at the bottom doing something, I'm not sure what, over there on the right part of the picture. On this one, the event that I remember is that we had trouble putting these gyroscopes in, and one of the things I was going to do to help my friends out for the next day was to hook up a cable on one of these instruments that I had pretty good access to through that part of the telescope to help them out with their job the next day. And I went and I got this cable. I put one hook on it, and I went to the telescope to install it. They said, "No, we gotta work. We're not getting these gyroscopes in, Mike. You have to go around the backside of the space shuttle and get another gyroscope that we weren't even planning to use. I wasn't even sure where it was, so I figured I had this cable flopping off me the whole time. It was just going to be on me for a couple seconds, but it ends up being on me for about an hour because we're having trouble with these gyroscopes. And at one point, I'm standing there toward the end of this hour with this thing still on me. I'm sitting on the outside of the telescope, and all of a sudden, I look through the corner of my eye, and I see the cable is no longer attached to me, and it's floating away. And really, it wasn't just the cable that's floating away, but I saw like the future of astronomy floating away from me through the corner of my eye. And the other thing that went through my mind was, we only have one of those. So this thing disappears, and I'm not going to want to go back inside. And so, but I just went up, and I was able to quickly grab it and hook it back up and avoid losing something. And no one really said anything until we landed, and then one of our instructors said, "Let me ask you something. During spacewalk number 2, did you lose anything?" Yeah. Because no one. I was amazed. No one said. They all saw it, or at least people who were paying attention saw it, but no one said anything to me. And I was able to grab it, and we completed the spacewalk, and everything was fine. This is a picture taken during the 3rd spacewalk, but what I wanted to show you here was we have one guy upside down and one guy on the robot arm. We always went out, it was 2 guys going out at a time. You always have a partner, and we generally had one person on the robot arm to handle big objects, and then a free-floating astronaut to scamper around and do the other work. And this picture I like because it shows you, as we're orbiting around during a spacewalk, you have this 45 minutes in darkness followed by 45 minutes in sunlight. It takes about 90 minutes to do a lap, one orbit around the Earth. So in a 24-hour period, you get 16 sunrises and sunsets when you're in space. And so you're outside for a spacewalk for between 7 or 8 hours, and so you get a few of these sunrises and sunsets. And what's cool about it is that you can actually feel it coming, because there's a big temperature change when you're in the sun versus in the dark. And you can see the line, which you can kind of see here, where as we're coming from darkness, we're coming into a sunrise. These folks, it's the dawn is coming, and you can see the whole thing rotate, which is really cool, because you can look down and you see that line that delineates night and daytime on the Earth. And as the Earth is rotating below you, you can see that line kind of track across. And it's pretty cool. It's like everyone's waking up below us here as we're flying by. And here's some footage from our spacewalks. A lot of this comes from our helmet cameras, so you get to see exactly what we see when we're spacewalking.
Open the doors, protective doors over the fixed head star trackers and the rate sensor units. And now looking from the opposite helmet cam, this view from Michael Good looking into the telescope at Mike Massimino.
So this is us. This is handing out. That's my hand handing out an old gyroscope unit to Mike. And these gyroscopes point the telescope very accurately. And there's Mike putting the new one in.
The new rate sensor unit.
Houston for EVA, we have a good aliveness test in RSU-2R. You have a go for RSU-3.
Mike was happy because we finally got the stuff in. Here's some footage of us changing out batteries on the telescope. These are big battery modules. They're not like little flashlight batteries. They're really big.
The 2-door has been engaged.
And now I was describing about this handrail earlier. You remember when I started talking about this handrail bolting in? So before I could do these 117 screws, I had to get this handrail off. And this one, 3 of the screws came out well, but that one on the bottom right would not come out. And it was like a nightmare for me. I could not get that. We tried a couple of things that don't work. So finally, the ground said, "Trisini, you just break it off." So this is what the solution was.
Okay, Nancy.
So you have all this high-tech stuff that we developed. It just came down to pulling the thing off the telescope.
Wide field camera. Well, yeah, main objective. Cold one might not come out. Don't break the drive thread. Then we can't get the RSUs in. It goes long. Then you're out there. You got a bar that you had to break off manually. Right. What's up with? Is that high tech? No. It'll be in my garage.
So my commander, I was interviewing my commander, and he said, "Is this high tech?" No, that's him. That's me in my garage, working on stuff. But all right, so this picture was taken after I broke the handrail off and fixed the instrument, and I was happy.
This man who was talking.
What's that?
A minute ago. Where was he?
Where was he? We were inside the space shuttle, on the flight deck of the space shuttle. Yeah, that was my commander. I was asking him what he thought. After everything was done, I was asking him what he thought. So that's what he was saying. This picture was taken at the end of my second spacewalk, when after the broken handle, and I was happy. And what was nice about this was I had my partner Mike Good still had some stuff to do, and I was pretty much done. So I was able to hang out by the airlock and wait for him for about 25 minutes, and it was beautiful. I had nothing to do but look. And the difference between looking out at the Earth through the window of the shuttle and then seeing it through your visor is significant. When you're looking at the Earth through the window of the shuttle, you're looking through a window, and you're wearing like regular clothes, and if you can eat something or drink something, if you need to go to the bathroom, you can. It's kind of like looking at an aquarium. Oh, look at the pretty fish, But when you go out on a spacewalk, now you're like a scuba diver, and you get out. I really feel like a spaceman. You're in your spacesuit, and you look, and you can look anywhere you want around your helmet, because there's nothing to restrict your view. You can turn and see everything, and you can see the whole Earth. It's big. It takes up your field of view. We're not that far away from it, but you can see the roundness and the curvature of it in front of you, and it's really spectacular. And the thought that went through my mind. This was my first flight when I saw it like this, and I really had a chance to look at it. I thought if you were in heaven, and you could look down on the Earth, this would be the view from heaven. And then I was replaced immediately by another thought, which was, no, it's more beautiful than that. This is what heaven must look like. And that's really the feeling I had. I felt like I was looking into paradise when I was viewing the planet from that vantage point. So it is just a great experience to be able to do a spacewalk. Okay. After we were done with our 5 spacewalks, we released the telescope, sent it on its way, and that's a picture of it after we were finished. Then I had plenty of time to look out the window and, of course, view this area of the world, which is where we are now. And Israel is pretty easy to pick up from space, because it's a nice green area, amongst the desert. You can see. Everyone knows what we're looking at here, right? We've got Israel from space. So, you looking for your house? Go find their home. Wait, looking for some land to buy, or what do you got? You looking over there? Yeah. So we were able to see Israel on certain passes pretty clearly. The sun was out most of the time when we were flying over it, so we got some pretty nice views of it. Here's some video on eating in space.
Flight engineers and Megan, what are you doing now?
Well, we just finished the starboard survey of the orbiter GPS, and I'm going to get my lunch. So I go to this block here that says MSQ meals on it, and I pull it out. It shows me all the food with the green dots. Mine that's in here, so that's kind of what I want to eat. This is what I was looking for, ravioli.
Oh man, it was great.
Very tasty.
I just had some.
So everything you do on Earth, you pretty much have to do in space, but you do it differently. We took some important objects with us, like we've seen the flag and the mezuzah. Can anyone guess what this is? It's a telescope. What's that? What? Columbus? Close. Galileo. Yes. It just so happened that we flew in 2009, a year ago, and it was the 400-year anniversary of Galileo making his observations of the heavens with his telescope. So it just coincided to be this anniversary, and we wanted to do something to pay tribute to Galileo. Plus, my background is Italian. My family immigrated from Italy to the United States, and Galileo did his thing in Italy. So, we thought this was a nice connection. So we contacted the proper authorities, or I'm not sure how it happened. Paolo Nespoli, who's an Italian astronaut, was able to help us out with this. And I remember I called him and said, you never know what Paolo's going to be. He's training for a space station flight. And sometimes he's in Russia, sometimes he's in Italy. He's all over the place. I don't know if he's ever been here, but he's been in lots of places. So I just happened to call him, or I wrote him an email, and I said, Paolo, I'm thinking of doing this. I want to do something for Galileo. He writes back, goes, Mike, I'm in Florence right now. I'm standing outside of Galileo's museum. I'm going to go find something. So then he comes. I see him later in the office a couple weeks later. He goes, we're going to try to get you. First, he wanted to get me like Galileo's original book that he wrote, like an edition from there, but it was worth like $1 million or something. It's like, I don't want to take that book. That's okay. So then he came up with the idea for the telescope replica, and he, sure enough, like, well, that sounds great. And they send the thing, but it was a little bit too long. It's about a meter long, and it doesn't fit in our locker. So I said, Paolo, what are we going to do with this thing? He goes, don't worry, I'll have it fixed. And he sent it back, and what they did is, you see this line right in the middle here? You haven't cut the thing in half. So it actually screwed together. So this is not the original. Of course, they would never do this with the original telescope. This is a replica. But this is an exact replica of Galileo's telescope, which was now cut in half so we could fit it in our locker. But we put two pieces together, and we were able to have a replica of Galileo's telescope, which started the study of astronomy, more or less, and flying on the shuttle with the Hubble Space Telescope, which is now the primary telescope that we use to look at the heavens. So we had where astronomy is now compared to where it started, and the 400th anniversary, and it was really very meaningful for us to have that as well. And then we talked about what we were able to do for Ilan and for Rona. Ilan was a very good friend, an excellent astronaut, and we miss him. And Ilan and his crew are always in our thoughts. And so every shuttle that flies, we always think of Ilan and the crew. And it was a real honor to have the Tel Aviv flag and the mezuzah with us. Every flight that we have, we're taking a piece of them with us. After having fun for 14 days, it was time for us to come home. And we pulled out our suits. Those are our orange suits again. And we launched with those suits. We put them away when we get to orbit, and then we put them back on so we're safe for landing. And here's some video about the lander.
Why don't you tell them about what you're going to be doing?
I'm going to be watching Shooter.
You're going to be watching Shooter.
Right.
What are you going to be looking for?
Well, I'm going to be looking to see that all the milestones.
Ray was our pilot, and Meg was our flight engineer.
To make sure he's on at the 180, but 180 degrees to this way.
You're talking about the big turn that we made. Before we turn final onto the land, onto the runway.
You can let me fly a little bit, and I'll fly around that cone a little bit. Yeah,
Okay. All right.
But then I'm going to make sure he's on his altitude, you know, when he's off the runway, and then 90 degrees out from the runway.
Right.
And as he rolls on final, he's all on altitude.
Right.
Airspeed's right, altitude's right, getting ready to land.
And if he's not, you're going to let him know.
Then I'm going to give him some sugar call.
All right, okay. What is sugar called?
Little rise, little up.
All right.
Little fast, little slow.
Okay.
You can do it. You're the man.
Tomorrow's a big day for you. I mean, you've had all kinds of big days, but is tomorrow kind of the biggest day for you at all?
Very special.
And that's because
Land. You know what? The robot doesn't land.
that's right. There's no auto land system here.
People get to land.
Right. You get the land.
And I was looking at my numbers. I think I have something like 3,000 guides approaches in that aircraft.
3,000 approaches. And those are all set up for the one you're going to do tomorrow, pretty much, right? That one. So there's a lot of practice that goes into this because this is a huge event. You're flying a spaceship and going to land it like a glider.
Right? It's only a glider. Right. It doesn't fly very well. You can't catch any lift.
Right.
Keep coming down all the way.
Like a brick, right? That's the same kind of like a brick coming down with these small wings compared to the size of the ship. And you don't have any engines, which means if you don't like what you see,
that's a big difference.
Yeah.
Maybe every time I came into the ship, sometimes it'd be moving around or I wouldn't be right.
Yeah.
They'd say, go around, try again.
Yeah.
Move the engines up and run. And this thing, you know, you're coming down. There's no going around. You're landing.
So this is...
You want to make sure you got the right stuff underneath you when you touch that.
That's very, very important. Can't say, I'm going to change my mind
No,
now.
if I go over here or there, no. You're coming down, you got to be in the right spot.
So that was our landing. The weather was bad in Florida. They like you to land in Florida because that's where you launch from. But luckily the weather was bad, and we had to stay up for an extra 2 days with nothing to do, which for me was great fun because we were ready. We even had our suits on, and they said, "No, we're not gonna land today." And the antenna where we send our email and all of our messages, that was already stowed, so we couldn't even do email or anything. It was great, and by definition, we were done with the mission, so they did with nothing. So we just had the opportunity to make some extra videos and take pictures and look out the window and listen to music, which was it was great to just be able to enjoy the experience of being up there. And then after 2 days of saying the weather was bad in Florida, the third day to try to get us back, they're like, all right, enough is enough. We're going to land you in California. So we came back to Edwards Air Force Base, and that was our landing. We worked on the telescope, and we thought everything we did was right, but you don't really know until they start turning the thing on and checking to see how the pictures look, what kind of images you're going to get. So a couple months after we got back, they released the first images that the telescope took with the new equipment in it, and I'm going to share some of those with you now. I have three images to show you. This is the first one. This is called Omega Centauri, and guess how many stars we're looking at in this image? Anyone want to?
10 million.
10. See, I hate when people. I should learn my lesson. 10 is nowhere near 10. Wait a minute.
10 million. 10 million.
All right, there's almost. No, it's not. In this picture, it's not 10 million. See, now the number I'm going to say is going to seem tiny. I should know I learned my lesson. It's 100,000 stars in this one image, but it's amongst the biggest group of stars of about 10 million stars. So the whole around this whole thing, that this is a part of a cluster of 10 million stars, but you're only looking at a mere 100,000 of them here, and they are about 16,000 light years away. I have to refer to my notes here because there's a lot of numbers involved. About 16,000 light years away. The thing is though these stars, each one of them is about the size of our sun. So think about that. You're looking at this as one image, 100,000 stars the size of our sun, plus around it, if you had a bigger, a wider field here, you'd be looking at the 10 million like you get. Did you know that? Did you
I confused the cluster with the actual.
Did you count them, or did you?
No, I didn't. I have the picture.
You have the picture. All right. Okay. This one is called Stephan's Quintet, and it's called a quintet because we have 5 galaxies. There's 2 in the middle are colliding. And there's 4 of them that are about the same color. Yeah? There's 4 that are kind of orangey, and then this nice bright white one to the left. And they show up in the same piece of sky, but they're at different distances. The brighter one up on the upper left is 40 million light years away. That's the closer one. The other 4 are all together, and they're about 300 million light years away. But they all show up in the same piece of the sky. And this is the last one I have for you today. This is the Butterfly Nebulae. And it's a dying star. It's in the Milky Way, which is our galaxy. So it's pretty close. It's only 3,800 light years away. Pretty close. And if you went from one end of this star to the other, from one end of the picture to the other, it would take you 2 light years to cross it. So that's the Butterfly Nebula. But that's just some of the first images that the telescope took after we got back from our mission. So that's all the pictures and movies and stuff I have. But I think we do have time for questions.
Yeah, sure.
Okay.
Thanks, Mike. Maybe 5-10 minutes for questions, and then we'll break.
Okay.
So, yeah.
How is it like being 2 mics on the same mission?
How is it like being 2 mics on the same mission? Confusing. So actually, we don't call each other Mike. What they really call me is Mass, because my last name is Massimino. So ever since I was a little kid, they called when I grew up in New York, they called me Mass. And my name, whenever I'd go to another, like I went to college, I said my name was Mike. But eventually gravitated to Mass, and the same thing happened in the astronaut program. So they call me Mass. And his last name is Good, so his nickname is Bueno, which is Spanish for good. So neither of us really are Mike. I'm Mass and he's Bueno. But that's how we took care of that problem.
Yeah. Apart from not being able to get the screw out of whatever you're trying to get the screw out, did you
The
have any
handrail.
other problems while you were up in space?
Did I have other problems? Yeah, we had lots of. We had the bolt that wouldn't go in the wide field that drew out a fix. These gyroscopes really gave us trouble. They did not. They're very precisely machined, as you can imagine, but we could not get this one gyroscope unit to fit, and that's when I had to scurry around. I almost lost that cable. But that was really perplexing because I would never imagine that the thing it just would not fit inside of it. And we had three units we were going to replace, and then we had a 4th one just in case. And that just in case one was, we thought we'd never have to use it, but we had to go back and get that, and that one did fit luckily, and we were able to get all the, get the functioning gyros in there. They later measured the one that we couldn't fit in, and they kind of cleared us that it wasn't us, that it was off a little bit. It was slightly off. And it's the way they built it, which they checked everything down to the smallest measurement. But so we never would have expected that, but that was the case. So there's always problems that arise. In fact, I think what we train for is when we're in the pool, we train. You're never going to get the same exact problem in the pool that you get in space. Plus, once you see it in the pool, then you know about it, and it's not going to happen to you. So you try to capture as many mistakes when you're training so you don't have them on the real day, And there's always going to be a couple that arise, but I think what we're training is how to deal with problems. Even if something's unrealistic in the water, you say, well, we're going to work through this problem and see how we're going to figure it out, because that's what happens. It's the same thing in space. So really what you're practicing, not necessarily for one particular problem, but how to solve problems. Like a good engineering education or a good science education. You're not going to get the same exact problem that you train for, but you learn how to solve problems. And that's what I think really our training is figuring out how to solve problems together, especially when you don't have that much time to think. and you get good at solving the problem, so when a new one comes up, you can recognize and engage it and fix it.
What are your sleeping arrangements?
What are the sleeping arrangements? The commander gets the good bed, and the rest of us get the cot. It's kind of like a big slumber party. We have sleeping bags, right? And they have hooks on them that you hook and you kind of tie it down. Because if you just got into a sleeping bag, everyone would be knocking into each other and waking up. So you take your sleep, you roll them up at night, and when you wake up, and when it's time to go to bed, you unroll your sleep. It's like a big bedroll sort of thing, and you hook it up. It's got all these hooks on it, so it's not going to float away too far. And then you get inside, and we normally have a sleep mask and earplugs because there's equipment noise in the back, and there's some lights on it. You'll leave a light in case you have to use the bathroom. So there's always like a light on somewhere, and so sleep mask, earplugs. It's generally a little bit cooler. We try to keep the space shuttle cool. It's just more comfortable and less likely that someone's going to feel, sweaty and ill. So we keep it a little cool. So you wear a sleep hat. But once you get inside that sleeping bag, you're just kind of floating inside of the bag, and that's pretty fun. And you can sleep any way you want. I slept on the ceiling. I slept upside down. Because once you close your eyes, you're just floating, and it's kind of cool to be able to do that. Can you still snore? I snore pretty badly on Earth, and but for some reason in space, no, people don't. I don't. I've been told I don't, and I've been around. We do a lot of. You do some outdoor training activities in the wilderness and stuff together to get. And boy, everyone snores pretty much. I think. But no, in space, snoring is not an issue. There's one big benefit of it. Go ahead, the New Yorker.
Why can't kids and teenagers go to the outer space? There were dogs and monkeys and adults, but not kids and teenagers.
Dogs, no kids? No teenagers. Well, I have two teenagers in my house. You really want me to tell you why I wouldn't want them to come to space? No, I think, the dogs and monkeys. The dog was the Russian dog, right? That they sent up. And the monkey, they sent up, I guess that was the first American in space was a monkey. But they didn't really have to do too much. The monkey would probably be pretty good at ripping off that handle. I don't think the dog would be able to. Now, I think it's just, if you look at the age of, for astronauts, I was selected when I was 33. It's kind of on the young side. Now I'm older than that. But generally, you need to get some credentials, education, and experiences to be an astronaut. And so it's hard for a teenager to have done all those things. So that's all it is, I think. And we're not at the point yet where we can send everybody. We're still somewhat in the era where we have to, where we're sending engineers, scientists of all types, but it's not open yet to families and really younger people. Now, if you're a really rich dude, if you can invent something and come up with a couple $100 million with some kind of internet invention or something, then you could buy your ticket. I think you could go. But there was people have been able to buy tickets or buy a seat on a Soyuz. I think the starting price was about $20 million. Then went to $30 million, and now I think it's going to go higher. Now with the space shuttle going away, I think it's in U.S. dollars we're looking over $50 million. So that's the other way. But I think a better plan for you would be. You seem like a very smart guy, right? These are folks sitting next to you. What do we got here? You know these people? Do you know this kid? He's a smart kid, isn't he? Yeah. So what you should do is really, and you're an Israeli citizen, I assume. We need some more Israeli astronauts, right? So what I would suggest is study hard, do the best you can in school, get some good experience, and apply. And I think you got some. That would be my advice. So.
Okay, maybe one more question. The back. Can't hear you. How to take this photograph?
How did they take this photograph? Okay. Well, I did not take this photograph. The telescope took this photograph. It's interesting the way the telescope works is it's got a lot of instruments. it's got four, what we call, like the big instrument I worked on, we call that an axial instrument, and it's about the size of a refrigerator. There's four of those, and it kind of in a circle around the telescope. And then there's the wide field camera that my friend had the problem with loosening the big bolt on that one on the first spacewalk. The wide field camera is a radial instrument. It looks like a big grand piano, a big piece of pie. There's four of those instruments. One wide field, and then there's these fine guidance sensors, which look like that, but they don't do the same thing. They take measurements. They don't take pictures. Anyway, the light comes in through the top of the telescope and then gets dispersed through all of these instruments, through all these cameras. Okay, so just like a regular Hubble, and you can find all kinds of images. Marty, there was something I wanted to give to you, and you're probably going to get really mad. I'm going to what? There's too many people waiting? I'm going to do it anyway. Marty, I have something for you as well, if you don't mind coming. Roni, you want to join me? I know I'm really embarrassing you, right? But he's going to kill me. But I just want to, Marty, Colin, go over here as well.
I want to be embarrassed together.
Marty has been a dear friend to, I know, to Corona and to me and to the entire astronaut community, through our whole office. And I'm really embarrassing him. And I think this shows his personality, that he works very hard and he doesn't take credit for anything. But he's such a good friend, and he's done a lot for our two countries to remain in contact with the space program that we have. Having Elon and the Israeli Space Agency working with, those are great years where we had you living in Houston with us, and to have that cooperation, that bond, that agreement of working together with Israel in space was just a wonderful program. And we're trying to keep it going, and Marty has done a lot of work to keep that relationship going. And so this is not just for me, Marty, this is for my entire crew. All right, we really appreciate everything you've done to keep that relationship going, and everything you've done to support the astronauts, and we hope to continue that for many, many years. So I know I'm embarrassing you beyond. And you're probably going to get me, he's probably going to throw me out of the country now. But this is from my crew, Martin. We wanted you to have it. We all signed it. It's Pat Settler's phone on my mission. It's the same assortment of pictures that we gave to the school in Toronto. And we want to thank you very much for everything you did. Okay.
אנחנו הכרנו בזמן שהיינו ביוסטון, והחברות בין המשפחות התקלקה מאוד, וכמובן לפני האסון נרתמו לגמרי, מאוד מעורבים במה שקורה בארץ בכלל ובאוניברסיטה, ובאמת כמו שהוא חבר קרוב שלנו, הפך להיות חבר קרוב של כל משרד האסטרונאוטים, וגם כנס החלל ו-Space Conference, the other activities that we're doing during the years, it's a great help and support. So thank you.
Okay. Thank you, Mike.
Thank you. Thank you very much.
Okay, with that, we come to the end of this afternoon's talk. I'd like to thank you all for coming, and to mention a few specific people who helped with the organization. From our department, Diana Laufer, Shoshi Barak, Zahava Eliezer, David Stiebelman, and again the Goldberg Group for helping make this event possible. For those who are staying to meet with the astronaut afterwards, we have a group with the students. We will start at 3:30, in another 20 minutes, in hall number 7 in Holzblatt, which is on the other side of this building. So thank you all for coming.